discussed aliasing. I said that happens, we can't avoid that. We should be careful about it. Multiple pointers point to the same location. And in our class, only one person was able to get the right answer, right? Then we discussed about dangling pointer, where we have no location but access to it. And dereferencing a dangling pointer normally succeeds, unfortunately, because memory allocation happens in pages and not bytes. So even though you free a part of it, the whole page is not free, therefore it exists, therefore dereferencing goes through. Very unfortunate that, right? And we also discussed about garbage. Garbage leads to memory leak, and garbage happens only when we have dynamic allocation. Without dynamic allocation, I cannot create garbage at all. Dangling pointer can happen with or without dynamic allocation, but memory leak happens only with dynamic allocation, right? Then we also said that when we use malloc, apart from allocating the required memory, it tracks how much memory is allocated. It has something called the bookkeeping or the housekeeping. That's what is used by free while deleting. So you should calling free on a pointer value which is not given by malloc is totally dangerous. It's an undefined behavior. We don't know what happens. In C and C++, we find a lot of undefined behavior, and unless you understand the philosophy of the languages, you will feel that the languages are terrible. There's one very interesting course called Principles of Programming Languages. Did any of you have a chance to study that? No? You had? Very unfortunate that it's not there at all. So yesterday I went with Dr. Viraj to BITS Pilani at Goa, and they have that course. The person whom we met yesterday is offering that course along with compiler design. In that course, you would get to know how languages are designed, what is the philosophy behind the design of languages. Very unfortunately, most of the universities today have dropped the course. They don't even offer that as an elective. So you should appreciate the philosophy. C and C++ are for efficiency. They do not care for safety. If you want safety, you do it yourself. They don't do it on their own. So if you have a dangling pointer dereference, anything may happen in the world, we don't know, right? I keep telling my students that when you try to solve MCQ on C, if you're not sure of the answer, pick up undefined behavior, likely your answer will be correct, right? Because there's so many things which are not defined and they look unusual unless you understand the philosophy of C and C++. Python is for flexibility. Python has obtained number of libraries, lot of interesting concepts built into Python. The concept of iterable, concept of callable, very, very interesting language that. And if you have algorithm with a particular efficiency, implement both in C and Python, there is no way a Python program can be as fast as C at all. It's impossible. The reason has to do with the runtime. In C, no type information is stored internally, right? And every decision about the type is made at compile time itself. Whereas in case of Python, type is a runtime mechanism, right? I can have a variable A, assign 10, it's an integer, assign 2.5 becomes a float, and that has to be tracked at runtime. That requires more effort. Not only that, whenever the index is out of bounds, it throws an exception. The minute you have exception, you pay for it. It doesn't come free. Even if there is no exception thrown, it doesn't come free because somebody has to be ready to catch it, right? So Python can never be as efficient as C or C++. But development time in Python will be far less because there are lots of interesting data structures, right? And one of our friends asked the question regarding Python and C and about the algorithms. If you are programming in Python, it's sufficient, it's efficient enough, go ahead with it. Don't ever have to change to C or C++. But sometime you could be stuck. You have a bottleneck which takes too much of time and you can't afford that, what do? Then plug in C or C++ at that point. Most of the projects in industry have multiple languages. Rarely I've seen a project with a single language. So you can call Python from C or C from Python. These concepts are called extending and embedding. And if you look at python.org, you'll be able to find documentation on how to extend and or embed different languages, right? That's a common requirement anyway. Okay, so that's the question I got, and I digress to talk about it. Any queries about what all we have discussed so far? Apart from pointer concept, we discussed one of the problems faced by John Bentley, Confession of the Programmer. If you're asked to sort a huge file, how do we go about doing it? One possibility, divide into parts and then use K-way merge. And in K-way merge, you may have to find the smallest element in K streams repeatedly. For that, the best data structure to use is the heap. Right? And then we said it's a better idea to analyze the problem domain before deciding the solution. And if you know that the elements are all integer and distinct, I can do that with an array of bits. I don't require to have anything else. I can use bucket sort, which will be linear, where any algorithm for comparison-based sorting will be n log n. Right? Just towards the end, we wrote a small program for matrix multiplication. And there was one thing that I used, which I said I will come back and discuss. One of our friends asked me that question. Good that he reminded me. I had already forgotten about it. Okay. How is a matrix stored in the memory of the computer? Memory is linear, so how do we store it? How do you make the matrix linear? Yeah. It's like making a long tail for a kite, right? So cut the matrix into parts and attach them. How do you cut them? Row wise, column wise, or some other way? Row wise, sure. Yeah, we're talking about row major and column major, right? It's row major in C and C++. It's column major in Fortran. But in case of Java, it's different. It's called row pointer. There'll be an array of pointers. Each pointer will point to a row. Okay, that means that's extra array of pointers there. We don't want to pay anything extra in C or C++. So if I have a matrix of, say, 5 cross 4, conceptually this is what we have, some 5 rows and 4 columns. And internally, it is stored continuously like this. 0th row, first row, the second row, the third row, and the fourth row. That's all that's stored internally. And A basically will be a pointer here. Okay. At runtime, array in C degenerates to a pointer. At compile time, it's an array. At compile time, the compiler knows that it's an array, it has 5 rows and 4 columns. But at runtime, nothing is known. All of them are forgotten. That's one of the reasons, again, why you cannot check for out of bounds, because the sizes are not even stored at runtime. Just like this. Now, if I were to give an expression like A of 3, 2, how would this work? In my program, if I have 3, 2, how will that work? So what the compiler will have to do is to take the value of A, to this add 3 times 4, skip 3 rows, and within this, pick up the second element. These two indices are coming from here. 4 is coming from here. Are you with me? When we have a row major fashion of storing, to find an element in the linear arrangement, I have to know the number of columns. Without knowing the number of columns, there is no way I can access the element. Are you with me? Right? If that is the case, when I were to call a function, if I had to specify the number of columns explicitly, then I have trouble, right? Okay, let's say I call the function, say foo with a. What is the corresponding declaration of the function? What shall I say? Yeah, what shall I say here? Void foo. Can I say like this? Int double star x, something like this. When I pass a 2D array as argument to your function, what is the corresponding parameter? Is that a pointer to pointer? The answer is no. Or can I say something like this? Void foo int x square bracket x another square bracket like this. Can I do this? No, because none of this will help me in finding the element. How about something like this? How about this? This size is not even required, we don't care. So what we should write could be either of these two. I could say int x square bracket 4, or I can say void foo int star of x of 4. When I pass a 2D array's argument to a function, the corresponding parameter is a pointer to an array. It's a pointer to an array of 4 elements. Both are basically same from the compiler point of view. Okay? Hope you are comfortable. 2D array is just an imagination of ours. At runtime, nothing is there, just an array, simple elements. And to access through the indices, I have to know the number of elements to skip each time the row number changes. That's the reason we require this particular value. And that's the reason, again, when I pass it as argument to a function, I require to specify. Parameter can never be an array in C or C++. They all be pointers. Are you with me? Now, if I have to write like this, hard code like this, can I use this function for some other 2D array? Unless the number of columns is the same, I can't use it. This was the limitation of the first C we got. C was revised in 99 first. The latest revision of C is 2017. In case any of you teach C now, you might have to go back to the standard. There are no books available at all. The last book was one of our friends asking. Second edition, I think, is the last book by Kernighan and Ritchie. And Ritchie wasn't very much happy with changing C. He was happy with the word C. He refused to enter into anything more. There was suggestion that merge C with C++, that also he didn't agree. So Ritchie was a great man, right? And so unusual. Do you know when Ritchie died? Dennis Ritchie died? Around the same time, another person died. Steve Jobs. Right? It was in every place, newspapers, magazine, TV. Was there any news about Ritchie's death? I'm told in Hindu, there was a small column which said Ritchie died. And believe me, we owe our food today to Ritchie's and Kernighans and Thompsons. Right? Ritchie developed C, along with Ken Thompson developed Unix. All things we use today either are based on C or Unix. And there was no news. So surprising. Ritchie did not want any popularity anyway. He didn't care at all. He moved out of AT&T and was never part of technology after that. Okay, we'll come back to this. So this was the limitation we had in Ritchie's C. When the standard came in, they said, okay, you can do something like this. You can develop a function wherein you can say that we would like to have a variable here. But this variable has to be a parameter, right? It has to be a parameter. I could give it earlier, there's no issue at all. I could say int 10 comma this, perfectly allowed. But normally, do you want to specify the size of the matrix first and then the matrix, or the other way? We are so much used to say matrix and then the size, right? So if I don't want to put int 10 earlier, I want to put int 10 later. Then the compiler will have trouble here. Compiler goes left to right. So he says, I don't know what n is, so it gives an error. Then what I want to say is, there is some n, I will give you a value later. So please remember that I'm going to give you n later, so this is the way I say here. This is declaring to the function to satisfy the compiler. There is an argument for n, which will come later. Do remember it at this point. Like we say, extend something sometime, right? It is equivalent to it. This came in C99. Without that, we had a lot of difficulty in writing functions for matrices. Okay, it's a sort of a forward declaration of a parameter. That's what I used. I think one of you asked me during the lunchtime. I said I'll come back and explain. Okay, that's about the synthetic feature. Now let's come back to our function, right? I changed the looping order. It suddenly became efficient. From 9 seconds to came to 4.5 seconds or something like that. How come that happened? How could that happen? Sir, why are you keeping a bottle in front of you? No, no problem at all. I'm just asking, why is that?
So that I can use it.
It has only water, right?
Yes.
And many of you have bottle, not just he, right? Just asked him, it could have been anybody else. Do they have a water dispenser outside? You can as well go and drink there. Why are you keeping this? Ma'am, the very serious question.
Convenient, it saves time.
Yeah, it saves time for you, you can have it. And maybe once it becomes empty, you can go back and check it from there. Yeah. Is a similar concept used in operating systems and computer organization? It's something similar. Yeah, cache, right? If you look at the hardware, which is the fastest memory location in the world? Registers. And if I can put all my program in the register, data in the registers, it will be the fastest. Not possible, right? Because there are only a few registers, very few registers. And I can put in memory, right? So whenever the CPU generates a virtual address, it has to be converted to a physical page, then find that location. If it is not there for some reason, you have to go to the hard disk, correct? So between registers and memory, can we have some other memory, which most likely it would be costly, but faster than the linear memory? That is the concept of cache, right? So if we have such a memory at all, whenever the CPU generates an address, what will that do? It tries to look in the cache first. If it is found, we say it's a hit. If it's a hit, use it directly. If there is a miss, then you may have to go back to the main memory. Sometimes you change the cache also, refresh the cache before using it, right? All of you know it, hit and miss. Now, if I were to walk through the elements in a 2D array, if I walk through the row, what will happen? If I walk through the column, what will happen? Let's say I walk through the column. Which elements will I access if I walk through the column? I'll access here, 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 and so on. Will they be contiguous in memory? But if you walk through a row, they'll be contiguous. So the programs follow a concept called the locality of reference, both something called temporal locality as well as spatial locality. So these spatial locality, the elements row-wise will be contiguous. So likely that all those elements could be in the cache when I go row-wise. Chances of getting a hit will be higher. But if I go through the column, I start getting elements which are not adjacent to each other, likely I may get more misses. It's always preferable to go through elements which are contiguous to increase the spatial locality of reference. Are you comfortable with the idea? Right? Now let's look at our program. Maybe can somebody put this on? Okay. Have a look at this. In this here, the number of access to the 2D array is 4. There are 4 accesses to the 2D array. And in this, which index is changing faster? K is changing faster. But if you look at the column index, 3 of them have J. If you change J, the elements will be contiguous. If you change K, the elements won't be contiguous. None of them will be contiguous, but this will be contiguous, others won't be contiguous. So the idea here is to look at the rightmost index and make it change faster. If each of them is different, nothing can be done. Now we observe that there are 3 cases where J is used, and that's what we did here. Put the Jth loop earlier. So all this indexing will be contiguous in memory. So this is cache friendly, right? So that's what I titled my talk today, Algorithms and Beyond. We have not even discussed what an algorithm is. We're discussing things which affect the implementation. So we discussed in the morning today the concept of loop invariants. So one more thing we're talking about is the cache coherence. So when you write an implementation, to make things faster, see to it that you access the same area as far as possible. Okay, just digressing a bit at this point, have you been told that function calls are costly? Is it what something we say? Normally function calls are costly. Why is a function call costly? Change of the state, some registers. Registers, some registers, so okay. That can't be very costly. Change the stack pointer, one move. Single instruction, maybe 4 T states, I don't know. I have forgotten T states long back. So, what makes a function call costly? In many languages today, we have a concept called inline function. Expand the code at the point of call. C has, C++ has. And that is used very, very heavily in compilers today. So what is special about a function call? Why is a function call costly? Apart from saving a state or changing a state, there's something that happens here. Address changing is very, very simple. One move instruction, right? And the move instruction is pretty simple, yeah? Did somebody say function name? Function name is not even there at runtime.
Function may not be there in the cache.
What? Okay, I like that. So there are 2 things to look at here. When we call a function, the instruction pointer has to change from the current place to the beginning of the function which is getting called. So my current function most probably will be in the cache, assume it's small. When I call a function, I must now go to the beginning of some other function. Is it likely to be in the cache? Very unlikely, right? That means now we start getting misses, then we have to replace it. At the end of the function, we return from there. Most probably by the time the old code would have been thrown out of cache, again we may have to refresh, right? So one point is that on a function call, with respect to the code, there is cache invalidation. Similarly with data, assume that you are now playing with an array in this function. You call another function, there may be some other array there. That may not be there in cache. Even with respect to data, it actually results in cache invalidation. Function call results in cache invalidation twice, on the call, on the return. That is the main reason why function calls are considered costlier. It's not because of creation of activation record, copying some values. They are a constant time, but cache invalidation is really going to matter. We have seen it here, right? From some 9 seconds, it came to 4.5 seconds. It matters a lot, right? Okay. What do we do? Okay, now we start some assignment. Okay, I'll keep giving you small things. You try, then I'll tell you what to do next. So, very small thing to write. Write a function to find all factors of a number. Very, very simple. Write a function to find all factors. Do it quickly and then tell me, then I'll ask you to do something else. So the function could be something like find all factors. Okay. So if I give a number like 28, I should get 1, 28, 1, 2, 4, 7, 14, 28. So I'll put that also. It's also a factor. Yes. If you forget 0 and 1, you have a lot of problem, right? How do you define multiplication without 1? So what? It's also a factor. You got it in the program? Show the program now, I want to see it. Then I will tell you what to do something else. Oh, you don't have a laptop today. And hers doesn't work.
So what I did is I'm given a loop. N is the number. N is the number for which I want to find
Okay.
multiple. So
Okay. I'll tell you something. This okay.
Yeah, mod.
No issues. It works. Okay, the function thing is not eaten away, so
yeah, I just
I think very hungry. Let's divide 28 by, say, 4. What's the quotient? Right? Is it possible to interchange these two? Can I interchange the divisor and the quotient? Possible, right?
yes.
So can I here output apart from I, n by I also? Can I output 2 factors at a time?
But what about the loops are there?
That's what I want you to think. You got it. You can get it.
You got
I just wrote the statement. I think it's just says anything, the loop, then you divide it by, you check
Okay.
the 0 and then you print.
sir told what you know.
What is it? Why is the first? Okay.
No, I thought you were supposed to store in and cancel.
Okay.
Those two numbers we directly introduce that.
So what I'm trying to say is, if I divide say 24 by 4, the divisor is 6,
Yeah, 6 for the 20.
right? Can I interchange the divisor and the quotient?
Yeah, because anyway 6.
4 6 is same as 6 4s, right? Yeah, it's the operation of multiplication is commutative.
Yeah.
So can you, when you say x equal to 0, can you output two numbers, I as well as n by I?
Yeah, if you perform division over here.
That no change at all. What I'm saying is, after if its condition is correct, you're outputting I, right?
Yeah.
Can you also output n by I?
N by I.
No. If 4 is a factor of 24, so also 6. Then in that case, can the looping be done better? So, it's a done.
I just wrote a loop, sir.
indent the program, no, otherwise it looks very bad. Its readability is lost, right? So, and one more thing is when I use a if, preferably use a block following it, so that even if you add something in the middle, no, you won't have any confusion. And also you would observe the way I key in. The minute I open if or while, I put a block. Okay. Now, think of this. Let's say take a number like 28. When you divide by 4, the quotient is 7. Is 7 also a factor? So can you get 2 factors at a time instead of 1 factor? So can you, here, I is a factor, right? N by I also is a factor. That means you can write that and maybe you can change the terminating condition of the loop. Think of that. Any results? So what did you do?
For factors, you asked, right?
Factors, yes.
So I'm a little doubtful. What's the factor of 0? I don't know. So I just put no factors. But for the iteration starts from 1 till the number itself.
Okay. Okay. So now I will give some suggestions. See if you can try. You divide a number, let's say n by I, you get a quotient. For example, if you take 24, divide by 4, 6 is a quotient. Is that also your divisor? Because the operation of division, multiplication is commutative.
So use it as a factor here.
Yeah, so while outputting, can you output 2 factors at a time? I as well as n by I.
Yes.
And that means can the looping stop earlier?
If the, yeah.
Okay.
If the mode is 0, there is no reminder, then the quotient as well as I both are the factors.
Correct. So if output 2 factors at a time, then the looping can stop earlier. You know, what's the condition you have put? Okay.
And displaying both.
No, that will be okay. But the first one I should check. What is that?
So that other I'm making as the terminating condition.
Wow, that's something unusual. Very something unusual. No, I think it's.
See, I'm making that other equal to n. So initially that I'm checking with n, but as I enter, once I find one factor, I'm making that other because I'm not going to go beyond that now.
Okay. See, the only point I would say is that this question, line number 4, is a trick. Making other equal to n is a trick, right? We prefer to avoid tricks. Nothing otherwise is okay. Now, so yesterday Viraj was talking about refute and programming, following program, right? So what I would suggest is try for number like 36. Walk through on the way I did, no? Just check and see whether it works for 36. So any of you ready to show me? Yeah. How do I see from here? Have you gone to Udupi by any chance? Udupi? No, you're not gone. So this. So you know Udupi. You know how the god is now, right? Suppose it turned around.
Yes.
So. Do you know Kannada by any chance? No Kannada. You speak Kannada. Okay. But mother tongue is Konkani.
So,
I have to keep putting it around. In place rotation. Who wrote this? You wrote it. And the person there with specs, you know him well? You know him. So there was some extra communication between you two. Some unusual communication between you two. He wrote the same thing. So great people think. Okay. So I'll also tell you what I asked him to do. Try your program for 36. 100 also is a good number. Huh? See, this line 15 is not a good one because you are playing a trick. You are saying country equal to n. What is that, right? It doesn't make
Same thing like what we did earlier.
it's not that meaningful initialization. But for 100, it shouldn't have worked. Did you run it?
Yeah.
Where?
It is saving 2 times. That's what
10 is coming twice.
twice. So that's why I was
Why you want 10 twice?
because I'm bringing here the factor of
So what do you think we should do? What do you think we should do?
I feel like I should keep statement.
You must try to come out one step earlier. Once coming out, you should check again whether such a thing is possible. How do I tell you? I don't want to tell everything to you.
It's like giving answer.
That's the reason. So you should try to run this one shot, and then after coming out, you should be able to get that value, the 10, and try with some other number also. We get an idea. The logic is fine, but this is something which I won't use, so I'm surprised about this way of condition. Right? I'm still a bit surprised. How come it is working 100? No, I first thought, based on what I saw there, that it will stop one step earlier, but it's doing one step extra.
Get out of this one step.
And don't use any break. Don't use break. Don't use continue. They're bad things to use. If you keep on dividing, right? So this becomes 50. Something is not okay with this logic. Something. You divide by 2. Can you try 36 or something? Can you modify and try?
Yeah.
Run it. Maybe she can run for us. I don't know this ID well, so.
Input change करें. 36.
Yeah.
Here it's the
Twice
same.
it's coming.
Twice it's coming.
No, I didn't observe earlier. One itself is missing.
Because I
One, she started with 2.
You saw it with 2. Okay. You may start with 1
okay.
because 1 also is a factor, right? 1 also is a factor. Okay. So okay, the only thing you have to take care of is this. I'll give my solution after a few minutes. Are you still stuck with n by 2 or did you make it n by 4? Or?
We came to know what is the problem.
So what is the solution?
Yes, sir.
You got a solution also.
No, we actually were trying that. only.
Okay, try. Then you can tell me.
We got this, sir, actually. But by considering n by 2, so I know now what is the problem. It is repeating the number.
So do you know where to stop? Look at the two values, relative values. There is some property which will change at a particular row, and based on that you decide.
Is this the way how you wanted that pairing? One
Correct.
And how to put the terminal condition when it reaches?
Continue further. Let's see what happens.
No, it cannot.
Just no. You start right then you'll know what it is. The next is what do you get?
Yeah, this is a combination
Wait,
which I got.
okay.
Wherein, no, this needn't have to repeat because
Okay,
actually
so
the
no,
redundant
okay,
of
okay,
the-
fine, correct, right?
Yeah.
You write this way,
Yeah.
and whatever that, right.
Yeah.
The first column is say I.
Yeah.
Next column is n by I.
Yeah. That is also fine. So that I
Wait.
can find.
Between I and n by I, there is some relation
Oh, that is what
which
we are not
which
able to
which
get
which
the
wait,
condition.
no, look at this, which holds until here doesn't hold here. What holds here? Check this.
Okay.
Compare I and n, I and this n by I.
Okay.
What is true here in these 4 cases? And that should not be true in the next part.
it's not raised to also.
It should be true here and false here.
Yeah, I understood. False here?
It should be false.
Because it should not. Because it's already
Correct.
taken.
So what is true and what is false here? Between I and n by I.
This is a. This should be lesser than this.
This is less than this, is not here.
Yeah.
Use that.
Oh, holy that much.
So why I less than n by I? Do that, then I will tell you something else.
No, that won't. That
It's almost correct, but something.
something is missing.
Yeah, there'll be a refute question you can ask. What happened?
By removing that, no, I'm not able to get any other logic. By removing the tricky
Forget the logic, but for 36, the 6 appears twice or something. That means you must have come
one statement.
outside the loop, not within. You should be outside the loop. Not within the loop. You should be outside. You must stop the loop one step earlier and check the outside.
So what I did is I was static value 20.
What is it?
Initially I was doing n by 2 and I was trying to print a value.
First thing is you don't require a loop in a loop
Okay.
because we are only finding factors of a given single number.
Okay.
So only one loop should be sufficient. And that
What I was trying to do is with multiplication to solve this.
you can do that. There's nothing wrong, but it's unnecessarily quadratic. Quadratic.
Yeah. But I was output like this. So the pairs were coming.
What is the number given? Input.
20 I had to.
Okay. So you're not getting one
I was not getting one.
because I think one you have missed. Not giving the total solution here. What you should observe is that if I take a number like say 24, one is a factor and n by I also is a factor. 1 is a factor, 24 is a factor, 2 is a factor, 12 is a factor, 3 is a factor, then 8 is a factor, 4 is a factor, 6, 5 is not a factor, 6 is a factor, 4 is a factor, 8 is a divisor, then I get 3, then 12 is a divisor, I get 2, and 24 is a divisor, I get 1, right? So my requirement is to stop at this point. I should not go to the remaining part. So what relation holds good between the first and the second column until here and not for the remaining part? Some relation between I and n by I which holds for the first part, not the second part. What relation holds good for the first part? What can we say about the relation here? In the part above? I is that okay? Where when you come to the next part, here I becomes greater than n by I. So if I were to rewrite the piece of code, okay, this is a refute question for somebody to check. Okay, yesterday Viraj was talking about lot about it, right? So what I will do here is to say I less than n by I is a non-negative number. So I can multiply throughout that inequality by I. It is same as saying I squared less than n. Can I say this? Because I is not a negative number. So I use that condition here. I don't want to use square root function. I don't want to go into floating point arithmetic. And here I will put two numbers. There is slash. Are you okay with this? N by 2 is not very meaningful. It's not going to reduce a lot, right? But this is a buggy program. Now, give a case for which it doesn't work. Think of a case for which this does not work. So, this is a buggy program. For some value, it won't work. Okay. Maybe I'll give an idea also. The value you can pick up will be within 10. Don't have to pick up a huge number and try. Within 10, you'll be able to refute this program. It doesn't work correctly. It doesn't work for 1. Does it work for 4? 4? 9 it won't work. For which numbers it won't work? You'll observe that this won't work for perfect squares. 1, 4, 9 it won't work because 1 squared less than 1 becomes false. We come out outputting nothing. Are you with me? So these are the questions you can give in the test, right? In your schools, your colleges. It's a good refute question to give. It does not work for perfect square because I squared less than n becomes false in the beginning itself. What do we do? Shall we say less than equal to? Do you think it's a good idea to use less than equal to instead? Then one other problem will happen. It will output the number twice, right? So how do you avoid that? If I use less than, for perfect square, it doesn't give the root. If you use less than equal to, it outputs this root of the perfect square twice. How do you avoid that? Whatever idea used, right? They have used, and he also is used. How come you have transmitted your ideas? Wi-Fi. They're not your friends. Not your friends. He's saying that they're your enemies. Friends. Him?
No communication.
Something has happened. Like this. 3 of you use the same idea. Something which is not common. Okay. So I was just saying, great people think alike. Okay. I could have said great men think alike, but then she will be offended. So, okay. Then the particular root will come twice. It will come twice. Each time you are outputting 2, right? Okay. So, the solution is you have to check whether I square is equal to n. Do not do it within the loop. Do not unnecessarily put a if statement within the loop. Once you come out of the loop, what is the relation of I squared and n? We come out when it is false, right? So what is the possibility? I squared is either equal to n or greater than n. Greater than n, I don't care. If it is equal to n, I output again. Yeah, you have to check it here only. You should never check in the loop. Checking in the loop will be extra overhead, right? So, make out this algorithm. The earlier one we wrote is linear, where this is I squared almost equal to n, or I is same as root n, so it is O of square root of n. Right? Earlier thing was O of n, this is O of square root of n. O of, if you say n by 2, it's no difference at all in algorithm. N by 2 is same as n, right? For large values of n, it doesn't matter. Are you okay with this? Okay, we'll try one more thing. Given a number n, okay, first thing we'll try this. Check whether a number is prime or not. Write a function is prime. Okay, then we'll use that to generate prime. Then also I'll teach you how to generate prime differently. Okay, so do not use break, do not use continue. The rule of programming in C and C++ is use break only if switch and no continue. They are bad habits. I missed one really good paper that we had in IIT Madras. We had a course called Management Information System. It was a useless course according to me. We studied COBOL. In one test, in COBOL, in 1 hour test, they had given 4 programs, each of around 20-25 lines. Each had some 4 go-tos. We had to remove the go-tos. We couldn't do more than 2. It was so difficult to understand the logic with go-tos. Same thing happened with break and continue. Normally, you should have a single entry and single exit, no multiple returns in a function too. Right? See if you can try it out. Yes. See, if you have got even number of factors, that means something is wrong. Huh?
That is not accessible outside.
Oh, did I do that? Thank you, thank you. A scope problem. Okay, I made a mistake in C here, not logic. This declaration has to be outside. Thank you for it. 2, I squared less than n. If it's a perfect square, it definitely is not a prime. So I don't have to check anything for it. And what do you think I should do within this? Okay. So one possibility is that I will use a variable which will indicate whether it's still possible prime or not. You might use the word flag. Please do not ever use flag. It doesn't indicate anything. It doesn't stand for anything. Don't call it X or Y. Make it meaningful. Maybe I can call it prime or something. Okay. I'll assume that it is true in the beginning. It's possible it's a prime. And while it is still possible that it's a prime, it's a candidate for prime, and the condition is still true, what do you think I should do here? If n modulo I is 0, what does it mean? Is the number prime or not prime? Not prime, right? So if it is not equal to 0, it is still a possible candidate for prime. I don't require any if statement at all. Look at this. And what do you think I should do once I come out? Once I come out, prime will be 1 if the number is prime. It will be 0 if the number is not prime, correct? So what shall I do? I write if prime, print it's the prime. Shall I do that? I should never print in this function. A function should print only if it is for printing. If I just print here, the next step I want to do is to generate all prime numbers. I can't use this. It has to return a value back. No printing it here. So I can just say return prime. I think you had a question to ask. Yeah, if I is, yeah, if I, it will anyway come out in the next iteration. It won't keep doing it, right? So if I return, then you'll be using multiple returns in a function. A program with multiple returns is difficult to read. When you're trying to understand a program, it becomes difficult in comprehension if there are multiple returns, breaks, and continues. There is a word like structured programming, right? The word came from Dijkstra. There is an article in a classical software engineering journal on structured programming. The title is structured programming. Within that, it's not defined. Even Dijkstra found it difficult to define what is structured programming. What is understood today is that any function that we write should have a single entry and a single exit. So we don't want to use multiple returns. We don't want to use break until it is switch. We don't want to use continue. I don't know whether any of you know, there were cases earlier in Fortran where you could enter a number of multiple different points. I could enter a function in the middle of it also. That was so crazy. Now that is totally gone almost now. Exit is possible with return even now, but not considered a good programming practice. Is that okay? Any queries about it? No if statements anywhere, right? No prints. I'm not checking for a perfect square because anyway perfect square is not a prime. Now can you use this to generate all prime numbers between 2 and n? Okay. Maybe what you could do in your student environment is ask one person write is prime, another person should use that and write generate, and they work separately and they should work together. Those experiments are nice in lab. The other person who is coming here on Friday, I don't know. He's from IIT Bombay, so I don't know him. Okay. So what I will do now is to show you a way of generating prime numbers without division, no division at all. And just to show you, if you're interested, I can write the same thing in Python in some 3-4 lines. Okay. See, it takes more time. I can do it also, but we'll just do this way. I'll show you the method. You can experiment. No division at all. It's a time space trade-off. Use more space. Of course, if you use bits, it will be also requiring less space. Okay. So the question we are trying to solve is to generate all primes between 2 and n, some n. Okay. So what I will do now is to create something called a sieve. This particular algorithm is called sieve of Eratosthenes. I have no idea when this person was around. Eratosthenes must be a very old algorithm, right? I think you should be knowing that the oldest algorithm ever known is what? Which is the oldest algorithm ever known? We use that in the morning today. It's the algorithm to find the greatest common divisor. It's called the Euclid's algorithm. It is supposed to be etched on a tablet in Mesopotamia. Okay. So now let's see how we go about doing this sieve of Eratosthenes. Is to generate prime numbers without division. Okay. You know what a sieve is, right? You filter things out, right? So what we do is, we put all the numbers from 2 to n into a sieve. I'll take sieve as say 25. So I'll take 2, 3, 4, 5, 6, 7, 8, 9, 10, all these numbers till 25 into a sieve. Okay. So in this, the smallest number is 2. That's a prime number. I remove that and its multiples from here. No division but addition. I remove all multiples of 2 from here. I sieve them out. The next smallest number is 3. That a prime again. I remove that and its multiples, if any. Next smallest number is 5. Remove the multiples of it. Oh, okay, sorry. Thank you. So 5. Next smallest number is 7. Next smallest number is 11. Next smallest number is 13. Next is 17. Next is 19. And next is 23. This is the way we generate. Okay. In case you want to implement this algorithm, how do you implement a sieve? What data structure would you use for a sieve? If you're doing the C, what do you use? Or if you're doing in Python or Java, what do you use? In C, you don't have to save the numbers. If you save the numbers directly, then shifting when you remove will be costly. You can have a fixed position for each number, the way we discussed earlier, right? So I can store 2 at index 2, 3 at index 3, 4 at index 4 and so on. The element is there or not there. So when I put the element, I put 1 there. I remove the element, make it 0. It's a logical deletion. Same thing happens in the database also, right? It doesn't always remove the record when you delete. Right? So, but if I'm using it in Python, I do that using the concept of sets. Okay? Set appears to be a much easier data structure to use. So we'll try to do it in Python, which takes a couple of minutes, right? And also you can do using bits. We didn't discuss bits to that extent in this course in the 2 days. So you can also use that in bits. You can have a single bit for each number, right? That also will save space. So how do you provide this? Okay. Oh, it doesn't have Python here. Okay, we'll use Windows for a change. No. So I'm trying to generate so I'll take input here. And then convert that to an integer. Inputs are always strings. I think it's at least 5 months since I wrote a program in Python. So hope I don't make mistakes. If I make mistakes, some of you will help me. So I got n. I had to create a set with all numbers from 2 to n. How do I do that? How do you get all numbers from 2 to n? I want to get 2, 3, 4, 5. It's an arithmetic progression, right? How do you get that? Use range. So range basically generates an arithmetic progression from 2, not n, n plus 1 because it is an open end. And this is an iterable. I can pass that iterable as argument for the constructor of the set. If I want to do something similar in C, I have to write a loop and go to each element in the array and make it one or whatever. I can just do like this. C is over. Okay. The next thing I want to say is, when the sieve is not empty, I should do something, right? So, while the sieve is not empty, do something. So, how do we say that? While what? How do you make out is empty or not empty? Can I say like this? The beauty of Python is that if a data structure is not empty, it is true. If it is empty, it is false. I don't even have to find the length, call other function. I can say while C. Okay. So what's the next thing I should do? Find multiples of some number and do something based on that. So what multiples should I find? Shall I say I start with 2 and find the multiples of 2? How do I find the multiples of 2? Multiples of I? Again, use a range. Use the range from I till n. What should be the step? I itself. Right? It's an arithmetic progression, 2, 4, 6, 8, whatever. And what I will do now is to convert that to a set. Okay? I have 2 sets now. One set is a sieve set. It has some elements. I have made another set now. I can give a name for it. Maybe I'll call it prime set. Not prime, let's say call it say multiples, some name. I should remove all these elements from the sieve. Right? I don't want to go to each of them and do it. How can I do it without that? I can use the concept of set difference. Right? Then one more thing which we haven't taken care is to find which is the prime number. We're not been displaying the prime number here. How do you think I should get the first number? It's almost there. So what do you think we should do? Sets are not indexable, right? So what I will do here is, if I in sieve, print that number, and do all this. If I is not in sieve, just increment it and proceed. Try the next possible number. Okay, but this is what is so interesting. You can use the set difference to make it faster. So have a look at this. And this indicates the power of Python. Writing a similar program in C would take time. C++ is more interesting. I can use set in C++ or Java, right? Okay. Okay, so I'll have to share these two separately. Okay, so this is yours now, and at this point I'm stopping. What did you want to take? These assignments only. So you can try and mail me tomorrow. Okay, with this, anyway, I'll mail it to Dr. Vandana. I think you'll get from her. Or if one of you give the idea, I'll also send, not a problem. So with this, I will stop the lecture, my lecture. So all yours now. You try it out. I'll be able to help you. I'll be leaving by around 4:50 or so. I want to meet Dr. Venkatesh on the way. Then I don't know what to do. I'll be sitting in the airport for 3 hours. So, yeah, my flight is at 10 o'clock. So I don't know. I can't even get sleep easily. Once in Singapore, my layoff was for 20 hours. That was the worst thing. By the time I landed, the flight left to India. Next flight to Madras was 20 hours after that. I don't know who booked the tickets for me. It was a retrieval. I told them it's not okay, but they didn't care. I had no choice. I had to come back. So my flight was from San Francisco to Hong Kong, Hong Kong to Singapore, Singapore to Chennai, Chennai to Bangalore. The flying time was around 25 hours, but totally I think it took 52 hours before I reached Bangalore from San Francisco. Okay, so I had to spend, I don't know what to do. Maybe I make a couple of phone calls. I have no idea. Yeah. Any of you are near the airport, you can come and we can have a chat. Yeah. Okay, so this is for you to try interesting exercises. Okay. So anything you want to tell me? Any comments, criticisms? Any queries? These fields are vast. Data structures and algorithms is a huge field. Normally, I would refuse to take this course again. I would say, give me a new course. Only course I would never say no was algorithms. I think I must have taught it 6 times, if not more, over 12 years. And again, I'm talking about the strength. When I joined, there were only 2 sections in the CS department, 2 in the IS. I only handled CS. After it became a university, first time I think we had 5 sections in CS. Now the intake is 780 in one college and 720 in the other college. So just that, 1,500 students studying computer science together in the same college. And there'll be one teacher who will be in charge of the whole thing across the 2 colleges. It's impossible. 15 teacher teaching what? No, it will be what? Tell you. It will be 25 sections. If single teacher has to take 25 sections, 25 into 4, 100 hours, 100 hours per week. I think you'll be dead. There'll be different teachers. There'll be one teacher called the anchor, and he drives the whole course. He will tell teachers, please teach this, and give inputs, because the anchor teacher will set the paper for all of them. It's all online. Okay. You want to see a paper? Long back? Okay. So, by looking at the output after some number of steps, can you make out what is the algorithm used? After 4 iterations, it looks like this. The numbers are 1 to 8, some shuffling. Can you make out whether it is bubble sort? Is it bubble sort? Why not? If it is bubble sort, the last 4 elements should be in order, right? Modified bubble sort is same as bubble sort. Only thing is, you stop quickly. Once you know that it's sorted, you stop. Otherwise, nothing great about modified bubble sort. Can there be selection sort? Possible, right? You select and put it in the right position. So it is selection sort, could be insertion sort, we can't make out on this. But out of these, selection sort is the best. What about this? This is very interesting. What would R to the power of I mean, sigma or I, R per I? If I increases, R per I increases, right? What sort of a progression is it? If R is 2, you get 2, 2 power 0, 2 power 1, 2 power 2, 2 power 2 squared and so on, 2 cubed and so on. What is that progression? It's a geometric progression. It's a geometric progression, right? So in a geometric progression, if R is very small, what happens? Which governs the whole thing? What is the value of it? Right? If R is small, the first term is the governing term. If you have A, AR, AR squared and so on, sum is given by A times R to the power of n minus 1 by R minus 1, right? So if R is small, R to the power n becomes very small. It becomes negligible. So effectively in the A to the power of R minus 1 by R will only turn out to be A. So it is constant, does not depend on R at all. So it is O of 1. Have you come across master theorem by any chance? Master theorem for complexity study? So there we use these ideas. Okay. And what about the next one? Maybe you want to check. In a sequence, we have 2 functions in a function. One is linear, other one is logarithmic. What is the total complexity of it? It depends upon the higher of the two. So linear is higher than logarithmic, so it will be linear, right? There is a theorem. Yesterday, this is a theorem he showed. He said there's a mistake in it, right? Dr. Viraj showed. If there are two complexities, you combine the two functions, you concatenate them, and the complexity will be that of the higher of the two, max of that. He showed that, and there's a refute question, if you remember, right? How about this? Okay. So the number of times we do will be based on log of n to base 2 here, because we are multiplying I each time. Okay. What do you think this particular code will do? Is an array being passed as argument. What is happening in this? T is assigned a of I is assigned a of n minus 1 minus I, and n minus 1 minus I is assigned t. What is happening here? Swap. So what could happen to the whole array when we do this? Reverse it. That's the normal answer people say. It is not totally correct because it will reverse twice. You get back the original array. If you don't start halfway, by the halfway the reversal is complete, right? If you do it, repeat the remaining portion, you get back the original array. So this should indicate what sort of questions we would ask, how we trouble our students, right? They may not get more than a minute to answer these. I think that just 1 minute or so. MCQ, right? Okay, I just want to show a paper. So we stop at this unless there are queries.